Good morning, everybody. I am Dr. Nguyen from FPT University. Today, I'm very glad to present our research on approach for SARS-CoV-2 infected case analysis. The author includes Đức Trung Trần, Hồng Sơn Hà, Dr. Nguyen, Rosdiasli Ibrahim, and Nguyen. The presentation includes 5 parts. The first part is introduction. The second part is methodology. The third part is result and analysis. The fourth part is conclusion, and the final part is acknowledgement. Now we come to the introduction. Since the end of 2019, many countries in the world have been facing against the COVID-19. The patient first of the disease was found at Wuhan city of China. Without the proper awareness of the newly discovered disease, it has been spreading around the globe. The COVID-19 is caused by a new kind of coronavirus, which was officially named as SARS-CoV-2. It can cause the serious acute respiratory syndrome on humans, which could be fatal. According to the statistics from World Health Organization, there are more than 6 million infected cases and near 400,000 deaths in total until June 2020, which prove that the disease is very dangerous. In order to prevent the COVID-19 from spreading widely, information about the disease should be delivered to people as soon as possible to help people protect themselves, reducing the infecting rate. Figure 1 presents an example which shows how most online newspapers reporting new COVID-19 infected cases in Vietnam. In the figure, the case numbers from 99 to 118 and from 319 to 328 were reported. The mentioned cases were detected from the 23rd March 2020 to the 13th May 2020 in Vietnam. In the majority, every case would be reported as a single article. Only some of them were merged into one. Hence, in order to get information of infected cases, many articles must be read. This could take some time for people to know all infected cases. To solve the mentioned problem, an algorithm for SARS-CoV-2 to summarize the reports will be introduced in the paper. Now we come to the second part, methodology. In this research, data and information of infected people in Vietnam was gotten from Vietnamese articles uploaded Vietnam, a reputable Vietnamese online newspaper. 52 cases were chosen to test the algorithm, and here is one of them. The proposed algorithm in this presentation will filter the information based on keywords. With the help of Pandas library, the results can be returned in CSV format. In Figure 2, the algorithm flowchart is presented. In the program using the proposed algorithm, essential information about infected patients, which are patient ID to identify each patient, since the name needs to be hidden due to privacy concerns. Gender, age, location, and current status can be returned. The algorithm takes a text file as input. After reading the file, patient's information will be separated based on the format of the information. An array is created to store the data of the patients. The algorithm searches the keywords in each case and returns it in a dictionary. The result in a CSV file will be exported by utilizing the pandas library. The detail of the proposed algorithm is demonstrated as following paragraph. The program will run through the input document, splits infected cases reports into cases, and then pushes the data into the array named case. The ID can be found by finding the first word of the paragraph. The patient's gender can be found by searching keyword male and female depending on the current number of infected cases, which in Vietnam is 1,000. The range of searching is first 40 characters. The gender variable will be assigned to the file gender value. If both cannot be found, the value for gender will be none. The gender finding algorithm is presented as follows. This slide demonstrates a method to find the patient's age. The algorithm will check if the word age exists in the report by getting the value of the age index variable, which contains the lowest index of the word age. If the value is not -1, then age exists in the report. The age variable is initialized at none. After detecting that age occurred, the age can be found before or after the word age 5 indexes. If the age cannot be found, then the program will return none. To increase the accuracy of the location detection, a list of provinces in Vietnam will be imported and read. Without the provinces list, finding the location should be more complicated since a location keyword could be confused with another keyword. After importing cities names, the algorithm shall begin looking for the first city appears in the paragraph. The detailed code is presented as follows. Last but not least, the status of the patient can be found by searching keywords matching the meaning of infected, cured, and dead. After determining the status variable will be assigned to the value confirmed, recovered, or dead respectively. After taking 52 infected cases as the input, there are 7 incorrect cases which are presented in table 3. Therefore, the accuracy of the algorithm is about 87%. In this case, the processing time was 0.103 milliseconds. The program only returned provinces instead of full location since the location is not in the city list. This could make the algorithm confused with the location which is the address of the patient. In the future work, text summarization, word segmentation, and word embedding algorithm will be applied to improve the program. In addition, it will be incorporated with an open toolbox for generating map of actively confirmed SARS-CoV-2 or COVID-19 cases in Vietnam. Now, we come to the conclusion. In this presentation, an algorithm to summarizing COVID-19 infected cases has been introduced. The program is expected to work with Vietnamese tech input. The information of the infected cases was successfully summarized as a table in CSV format, which contains patient ID, gender, age, address, and status. However, some wrong cases occurred due to incorrectly age and location detection. The algorithm will be improved to work with multilingual information as well as correct the wrong cases by applying some technologies such as text summarization, word segmentation, and word embedding in later researches. Finally, the authors would thank APT Corporation for supporting this research. Our presentation ends here. Thanks for your attention.